So now it seems we're gone. Somebody sent a message here that I didn't see. Sure. There's already a group for this class. Yeah, we talked about that the first day of class. And I was saying, if you guys don't mind, you could put me in there. If you just want it to be your own thing, so it's fine. You don't put me there. So we are still gonna be fine. But if you have questions there that needs to be sent to me, please send them to me. All right, so I love this kind of screen. So differential equations, lecture 3, exact differential equations. So what do we call an exact differential equation? So it would be an equation of the kind m of xy dx plus n of xy dy equal 0. Notice that this formula is the same formula that we had for homogeneous equations, right? The only difference now is the condition. We had one condition there for the equation to be homogeneous. We have a different condition now for the equation to be exact. The condition is this, such that if we take the derivative of m with respect to y, it's going to be equal to the derivative with respect to x of n of xy. So we take this function, we take the derivative with respect to y, and we take this other function and we take its derivative with respect to x. If the two things that we get are same, then we say that the equation is exact. If you have that equality, then you conclude that the equation is exact. Anybody see that? Okay, so first, let's look at an example. You have 2xy dx plus x squared minus 1 dy equal 0. And now let me, on this example, show you what I was explaining earlier, that some problems might be in many sections. This equation, if I don't tell you solve it as an exact equation, this is actually a separable equation because I can get all the x's on one side and all the y's on the other side. So it is a separable equation. But here, it is given to you in the section of exact equations. So you have to solve it as an exact equation, even though you are also able to solve it as a separable equation. Now, how do we show that this is a separable equation? That's m. M is always what is in front of dx. Very important to keep that in mind. M is what is in front of dx with everything that it contains, including signs, numbers, coefficients, everything. N is what is in front of dy, same, including everything that comes with it, signs, coefficients, everything. So that's n all the way up to the sign. Here the sign is plus, so no problem. If that was minus, you'll take it with that minus. And so we got our m and our n. And we need to check this. And I need to explain this somehow. Here, technically, some of you might have a problem because they have not yet taken Calculus 4. And what we write here is what we call a partial derivative. So you have a function that has two variables, but you take the derivative with respect to one variable. And as you are doing that, you assume that everything else that is in the function is a constant. So if I say take partial derivative with respect to y, that means I'm assuming that x is a constant, a number like 1, 2, 3. When I'm taking derivative with respect to x, I'm assuming that everything else, including y, is a constant. And that's how you should understand that if you haven't taken the Calc 4 course yet and you're having issues with it. So how do I do that here? Derivative of m with respect to y, in this case, is what? So that's m, 2xy. I take derivative with respect to y. 2x is a constant, so I write 2x. Derivative of y with respect to y is 1, right? So that is 2x times 1. So this derivative is 2x. And then derivative of n with respect to y, and this is n plus x squared minus 1. Derivative with respect to x, sorry, we take derivative of n with respect to x, not with respect to y. The derivative with respect to y of x squared minus 1 is 2x, right? And there is nothing else. And now you can see that these two things are equal. When those two derivatives are equal, we decide that the equation is exact. Any questions?
Does it matter if, like, you said you take the derivative with respect to x for n? Does it matter if you do y with that one and x with the other one?
It matters. That's why I'm telling you clearly that
Okay.
your m must be what is in front of dx and your n must be what is in front of dy. Otherwise, the whole thing is wrong.
Okay.
You're not going to get anywhere if you switch at any point. And that is important even in the steps of solving the problem. You will see how important it is to identify the correct m and the correct n. You get them wrong, your whole problem is gone. Anything else? Again, the most difficult thing here is to make sure you know how to take the derivatives, right? When you're taking derivative with respect to x, you assume that y is a constant. When you take a derivative with respect to y, you assume that x is a constant. All right. Example 2. Let's say we have 2xy plus x dx plus x squared minus 1 minus y dy equals 0. So in this case, this is m. and that's y, that's n. Again, you take derivative of m with respect to y, xy. What is this equal to? So we start here. That is 2x is a constant when I'm taking derivative with respect to y. Derivative of y with respect to y is 1 plus x is a constant and there is no y. Derivative of 1 is 0. So that part is going to have derivative 0 because there is no y there. And derivative of n with respect to x equals, again here, that is 2x minus y, and derivative of 1 is 0 because there is no x in this on this part. So this is 2x and that is 2x, and also you can see that the two derivatives are equal. And when the two derivatives are equal, the equation is exact. Okay. So we have two examples of exact equation. Let me give you one that is not exact so that people will not start believing that all equations are exact. We just need to take those derivatives and say that they are equal, right? They are not always equal. So for instance, negative 2x e to the y dx plus 1 over y x dy equals 0. This equation is also a separable equation, but here it's in the section of exact equation, and the question is this an exact equation? So here is the m. Notice that it includes the sign that is there. So that's m of xy, and this is n of xy. Also notice that I don't put dx and dy into m and n, so those are not part of the functions m and n. And so once you have this, you take the derivative of m with respect to y. That's minus 2x stays. And then derivative of e to the y with respect to y is e to the y. So this is the derivative of m with respect to y. Then we take the derivative of n with respect to x. 1 over y has nothing to do with x, it stays, and then x, derivative of x is 1 with respect to x. So the answer here is 1 over y. And you can see these two things are not equal. They are not equal because this is 1 over y and that's negative 2x e to the y. The two functions are not same. And if they are not same, then the equation is not exact. That's it. Then you get that, you say, hallelujah, thank God everything is going to be perfect in this class. That's A. Questions, please.
I don't know if you already said this. If you did, I'm sorry, but when we're solving them as exact differential equations, do we have to solve them in a totally separate, uh, like
Wait.
using a totally separate method?
Yes, that's what I will give you after convincing you that it is a completely different type of problem. I'll tell you now how to solve it.
Oh, okay, thank you.
It's a completely different method. So once you establish that the problem is exact, then you have a tool to solve. If you establish that the problem is homogeneous, then you have a tool for it. If you establish it is separable, then you have a tool. You see how it works. So every time you are told that it is homogeneous, it's requiring a specific tool. If you say it's separable, it's requiring the tool of separable. If it says it is exact, then it is requiring the tool of exact equation. And after that, you will have others. You will have linear, you will have Bernoulli, and so on. And that's also one of the reasons why I say practice as we go, because if you don't, then at the end of the day, when you get close to the test, you're overwhelmed because you don't know what goes where, right? And at that point, it is unrealistic to think that you get it in 2 days to get it correct on the test, because each of the classes that you have is a method that is completely different of the others, and that sometimes even requires knowledge from the others to be completed. Other questions? All right, if no questions anymore, let me now tell you how to solve the equation once it is established that it is exact. So that's the second part of the lecture, to solving exact equations. And again, here, what I'm giving you is exactly what is being done in the textbook, just that I bullet point what I think are the important steps of the process. That if you know here, this is what I'm doing, then you're going to be okay. So, it's step by step. So in step 1, of course, I say, write down. Before even getting to the steps, let me tell you what it is about actually. When the equation is exact, that means there exists a function f of xy such that the solution of the equation can be written as f of xy equals c for some real number c. So when we have an exact equation, it means that there exists a function f of xy such that the solution of the equation can be written as f of xy equals c. If you already had Calc 4, I could take class time to explain why this is equivalent to the condition that is written for an equation to be exact. But because most of you don't take that before getting into this course, because it's not more a requirement, it was first a prerequisite for this class to take Calc 4 before taking the class, but then it was reduced down to Calc 3. So that's the reason why some people might find sometimes this topic a bit confusing, because you're not prepared for the topic that is used inside of it. But again, it's the only place in this course that requires knowledge from Calc 4. So that's the reason why the prerequisite was removed, because they don't want you to spend one semester just because you need one topic to be used in one topic of a class that has maybe 20 topics, right? So, and now this is what it means. So, and if this is the case, then in the equation that we have, the derivative of f with respect to x is actually m of xy when the equation is exact and f of xy equals c is the solution. Then the derivative of f with respect to x is m, and the derivative of f with respect to y is n of xy. And this is why it is important to know that n is in front of the x and m is in front of, sorry, that m is in front of dx and n is in front of dy, because they are different derivatives. That's the derivative with respect to x, and this is the derivative with respect to y of the same function, f. And our goal when we want to solve this problem is to go backwards, use these two equalities to find the solution, f. Finding the function f is the goal. So solving the equation is equivalent to finding the function f. And in doing so, the step one is write m equals derivative of f with respect to x, m being what you have in the equation, right? So you copy that m from the equation and write that. And n is derivative of f with respect to y. So you copy the n from the equation and then set it equal to derivative of f with respect to y. You have those two things in front of you, and then you go to step two. Here, usually I say you have a choice, either start by m or by n, but in this lecture, I'll just give you starting with 1m all the way to the end. You know that if you flip, you have to change everything in between symmetrically. So integrate m to get f of xy equals integral of m of xy dx. So because m is the derivative with respect to x of f, f is the integral of m. That's doing backwards, what you called in Calc 2 entire derivative, right? You take the entire derivative. But now in this entire derivative, when you're doing it, you need to remember that there is a constant of integration. Usually we put plus c, right? But because we are integrating a function of two variables, and just as for the derivatives that I talked to you about earlier, when I integrate with respect to x, y is a constant. So I assume that y is a constant. So this constant y goes into the constant of integration. That's why instead of writing c in this course, we write h of y. That's the constant of integration. So in this class, the constant of integration turns into a function of y, because when you're integrating with respect to x, y is a constant, and thus it goes into the constant of integration. So after doing this, you head to the third step, where you find derivative of f with respect to y. Using what you have here, find the derivative of this f that you found here. So you integrate this, then you find the derivative. That derivative is going to be something plus, and the derivative with respect to y here is going to be h prime of y, because there is only y in that function. So you find that derivative. And then on step 4, you set that derivative that you found here equal to n. So you set that derivative equal to n of xy. N of xy being what you had in the original equation. So when you do that, that is this plus h prime of y equals n of xy. So this is the equation that you get when you set that. And then here, in the next step, I say solve for h prime of y. Solve this thing for h prime of y. When you solve this for h prime of y, what is it? It just means send everything that you have here to the right-hand side. That's it. That's what it means, solve for h prime. You take everything that is here, you send it to the right-hand side, and you have h prime of y. Now, that's the most important thing at this point. Make sure you simplify and see that there is no x left in the equation. So after this step, there should be no x in the equation. So when you solve for h prime of y, x must disappear. If x doesn't disappear, then you have a mistake somewhere. Check. And now after that, you integrate h prime of y to get h of y. And after your integration, put h of y into the equation that you have here for h of y, for f of xy equals that integral that you had at the beginning knowing that you already know this, already computed. All you do is just bring h of y into it and replace. And that's it, you got f of xy. Done, problem solved like magic. And it's the perfect thing. You can never miss it if you follow that. And the last thing you do is just set f of xy equals c. This step is often forgotten by some students. If you forget that, you don't have the answer to the problem. You just found f. But the solution of the problem is really f of xy equals c. And then the last step, which is not always there, So use the initial values if they are given. Use your initial values if they are given. That's it. That's the full package for this problem. You have that, you have the magic solution. You do it 100 times, you get 100 times 100 points. What? That's it, 10,000 points. Questions? Before we do examples, any questions on the procedure? You understand why we go from one step to another? If you actually understand why we go from one step to another, it's easier for you to actually do it without having to memorize this, right? Questions, please? One.
All right. So you said that there are different ways. Would you have us solve it using N? Like instead of starting off with M, could we start off using N?
Yeah, that would be your choice, but then you will have to flip everything that I wrote inside here. Whatever is done for X, you do it for Y. Whatever is done for Y, you do it for X, and if you do it the other way around.
So would you recommend us just whenever we have an exact equation to always solve it with M, or would you have us use N in some cases?
I always leave it to you to choose. And basically, technically, there's no difference between the two things, whether you start by N or you start by M. That depends on the functions that you have and what you feel better about. If you feel better integrating M, you can start by M. If you feel better integrating N first, you can do that. But it won't change anything on your answer. And I will never force you to start by anything. I always leave that choice, you know.
Okay, thank you.
Mm-hmm. And again, if you choose to start by N, then you have to flip the steps. The same steps remain, but for example, if you say I start here by N, then you are integrating N dy, right? And then plus H of X. So you had to flip everything. Everything that you did for X, you do it for Y. Everything you did for Y, you do it for X. And then here you would be setting derivative with respect to X equal, and then here H prime of X. You continue here, you could be setting this equal to M instead of N, right? So everything you just have to flip around. Everything that was related to N, to X goes to Y, and everything that was related to Y goes to X. But not to confuse people, I don't usually write down this two set of things. Just write this down. If you do this all the way 1, 2, 3 times with one, then the other way around, you will do it without problems. Other questions? Did I answer your question, sir?
Yeah, you did.
Okay, so any other questions on this?
So h of y is always going to be the constant of integration because there's a constant already in the function?
Yes, because y was a constant in the function, h of y is always going to be the constant of integration. And again, thank you for that question. The way this thing works is that if you actually copy these steps that I put down, right? The only thing that would change from one problem to another is to go into my steps and put in N and M and just continue. Everything will just go same. Just keep that N, keep that H, keep that F, and then you bring in N and M, substitute them in this solution. That's it. Just compute the integrals and all the things that I say, do this, and you just do that and you get the answer. That's it. Nothing new coming in.
Okay, thank you.
So that's the way I use to put it for students, trying to put it down to the easiest steps that need to be completed for it to be perhaps understandable to my point of view. So, and if you do that, that's it. Most of the time it works for most of the students when you follow that. You have less you know, less time thinking about how to do it, and just do it because you have it, right? Any other questions? Okay, so now we are going to solve concrete examples, applying exactly the steps as they are, okay? Unfortunately, I can't split my screen in two, but I'll just try to put a paper next to another one so that you can see the steps while I write down the problem. So we can see the steps, right? It will be blurry a little bit, but it's not that a big deal because you have them already. And I will write the problems right here. So let's work the first example that I gave you. Example one was 2xy dx plus x squared minus 1 dy equals 0. That was example one. And so step one says, write m equals df over dx and n equals dn over dy. So I just do that. I say derivative of f with respect to x equals m. That's m is everything that is in front of dx, so that is 2xy. And then derivative of f with respect to y equals n, which is everything including the sign. So that is x squared minus 1. That's step one. Right away, you copied m and n, that's it, done. You just now follow the steps. Next step says integrate m. So to get f of xy equals integral of 2xy dx, integral of m dx. That's step one. Integrate m to get f. And now you compute this integral. So again, what I said, please follow carefully these integration that I'm going to do now. Same as for derivatives, when you're integrating with respect to x, y is a constant, so we can remove it from the integral. So we remove the constant from this integral, that is 2y integral of x dx. That's how we integrate when we have a constant, right? We remove the constant from the integral and we can integrate the rest. Now, what is the integral of x dx? That you know.
One.
Integral, not derivative.
1/2 x squared
1/2 x squared. So
plus a constant.
plus the constant. So now this is going to be 2y and 1/2 x squared. And that will be plus the constant of integration h of y, which is what we said in this question when you integrate. And that is, you simplify this, that's yx squared plus h of y. That's step two. Take that integral plus h of y. Then step three. Step three said, take this derivative. That's step three. All you do is take the derivative of this. So derivative of f with respect to y, that's what the step says. Take the derivative with respect to y. What's the derivative of this thing with respect to y? That would be, help me here, please. I love it.
X squared plus h prime of y.
Good. X squared plus h prime of y. I actually love it when people participate in the class because it makes the class a lively place, you know. Don't just take a one-man show here. We have friends. We interact. So that's the derivative. Does everybody understand why it is x squared?
Yes.
Because that is y times x squared, right? X squared is a constant, so it stays, and then we take derivative of y, that's 1. 1 times x squared is x squared. That's what she did. Thank you, Messi. All right. So that's all you need to do in step 3. Take that derivative. Simple step. Next step. Next step said, set that derivative that you got here equal to n that you wrote up there. That's it. That's the step. Take this derivative, set it equal to that guy. So that's going to be x squared plus h prime of y equals x squared minus 1. Oh, yes. That's what step 4 is about. So you take your derivative you got on the previous step, set it equal to n from the original problem that you wrote on the first line. Now on step 5, what you do is solve. I said solve for h prime, which said take everything here, send it to the right. So h prime of y is x squared minus 1 minus x squared. So I send the x squared to the other side. And then you can see that x squared and x squared cancel, and this is equal to minus 1. And now when you see that, you remember that in the lecture, I told you that when you will do that on step 5, x must disappear, right? Did that happen? Yes, it did. So x disappeared. Now you got h prime of y equals negative 1. That's it. Step done. And now you go to step 6, which says integrate h prime of y to find h of y. H of y is integral of h prime of y dy. And this is integral on h prime of y, you found it here. Integral of negative 1 dy. And this is negative, what's the integral here, by the way? You can help me?
Negative y.
Negative y, perfect. And here, technically, I don't bother about the constant of integration because I know that I have it at the end here. Otherwise, I'll need to put a plus c here, okay? Otherwise, someone would say, hey, this is wrong. This guy is putting some wrong shit on the board here because integral has to go with the constant of integration. No, I don't put the constant integration here because I know it's coming next on my step 8. So here, we're going to say step 7, put h of y into the formula of f of xy. Where is the formula of f of xy? It's right here in step 2. That's it, right there. That's it. So just get into that formula and you replace h of y by what you just found here. So f of xy equals x squared times y plus h of y, which is minus y. So that is yx squared minus y. So this is it. Perfect. And now your step 8 says, I will set that thing equal to c. So you get f of xy equals c, which means yx squared minus y equals c. That's it. End of the solution. You got it. We don't need the last step, use the initial values, because we didn't have some in this problem. So that's it. That's a final answer. And if you want to show me that you're smarter, you can solve for y and say y equals c over x squared minus 1. I'll be happy, but I'll give you more credit. You still get the same credit as the person who stopped here. And you have a chance of losing some credit if you try to solve and you give me a wrong answer. So I always advise to stop there if you finish there, because you don't risk losing points. You know, what's the point of trying to write something down that will in any case not give you any points, but you have a chance of losing points, right? So point wise, it's not beneficial, right? Just don't do it. Any questions on this solution? Anyone likes it?
I think it's very satisfying just to see it all come together.
Right. Thank you. Now let me keep this example on the board and then write another one and pray God that you get it right. Now, example 2. And this will be your exercise. You get 2x over y dx minus x squared over y squared dy equals 0. So I give you this equation and I say, please take about 5 minutes and follow the steps on it. So we have the steps right here, and we have them in this example that is right there. Is it coming along?
Yes.
Okay. So please do let me know when you're done with one so that we can go together with your steps and you'll be telling us what you get. Can you please tell me what you get on step 1 already?
So what you do, you set 2x over y equal to df over dx.
df over dx is 2x over y, correct? And df over dy is?
Negative x squared over y squared.
Correct. That's the correct first step. Now on step 2. Anyone with the correct step 2?
I integrated m to get x squared over y plus h of y.
That's integral of 2x over y dx. That gives you x squared over y plus h of y. That's correct. Because the integral, y comes out, the integral of 2x dx is x squared. So x squared over y plus the constant of integration, that's this step. So we do get that one correct. That's correct. 2 steps. Third step. Who has the correct third step?
You take the derivative of f of xy, which will give you with respect to y, which will give you negative x squared over y squared plus h prime of y.
Correct. And why would this be correct? Because when you take derivative with respect to y, x squared is a constant. X squared comes out. Derivative of 1 over y is minus 1 over y squared. That's why she gets negative x squared over y squared plus h prime of y. So this is the correct third step. And what does the fourth step say? Anyone with the correct fourth step?
You set that equal, you set df dy equal to n of xy.
So what is that? You just read me what you get there.
I got, so negative x squared over y squared plus h prime of y. I set that equal to negative x squared over y squared.
That's correct. Negative x squared over y squared. So the most important thing in all this is to be able to know exactly what goes where. When you know that, the solution just comes, right? Now we go in fifth step. What does the fifth step say? Solve, right? Solve for h prime, which means take all the things and put the other side. So you get h prime of y as negative x squared over y squared minus negative x squared over y squared. This comes to the right, and this gives you 0. And I say this is a smiling 0. Right? Because that is negative x squared over y squared minus that's plus x squared over y squared. So it gives you a 0. So, and this 0, like I said, it smiles. Now let's say it's even a girl. It is smiling because that's the easiest thing that you want to have to integrate. What's the integral of 0?
It's just a constant.
Yeah, but because we don't take care of the constants, as in this case, what is it?
Oh, is it just 0?
0.
Yeah, it's just 0. So I actually wanted to show that 0, but this camera is not seeing it. Yeah, it's 0. So that's 0. So our sixth step, where it says integrate, will just give us h of y equals integral of h prime of y dy equal integral of 0 dy equals 0. Yes. And we don't need to care about the constant because we know it's coming next. And step 7 says, put h of y into the formula of f of xy. What did you get there? What is f of xy? From here, right here.
X squared plus y, or x squared over y.
Plus 0, which is just x squared over y in this case. And then you go to step 8, which says set the whole thing equal to c, so you get f xy equals c, which means x squared over y equals c. That's it. End of story. No step 9 needed because we don't have initial values. See that? So we're perfect. We're already specialists. It comes, it's clean, and we got it. Or here you could solve it and say y equals a constant times x squared and where your constant is 1 over c. That's it. Oh, wait, man, this screen looks beautiful, don't you think so?
So just to be sure, where we have the x squared over y equals c, we can stop there, right?
Yeah, that's what I said in the previous problem, right? You could stop there. I just wanted to look smart here. So, and I turned it to y equals kx squared, and where k is 1 over c, but it's really not a needed action.
Okay, just making sure.
Yeah, you're right. It's good to ask always. Any other questions? Again, the most difficult things that you will have in this topic is knowing how to integrate and knowing how to take the derivatives, because that's where most of the time my students fail, because you can see that all the steps are there. The student knows what to do, but it's not getting the solution because he doesn't know how to integrate or how to take the derivatives. So please work on that. If you have issues, make sure you know how to take the integrals and the derivatives. Any other questions? Shall we do another example, or I can try to show you something else?
You can show us something else.
Something else? Is that a 23 votes for that?
I'm down for something else as well.
Okay, that is 2,
Yes, that sounds fun.
3,
Sounds good to me.
4.
Sounds good.
6, 7. Do I have that 7? Yeah, I'm not saying it. So we have only 6 out of 23 answering. So how can we decide an election when you don't even have 50% of the electorate? Hmm?
I did the reaction.
I want them to vote, and they don't want to vote. I was taught that in this country, we need to vote on everything. So I always ask. In my country, we just do what they ask us to do. If the instructor wrote on the board something, that's it. Just take it or leave it. It's up to you until you see what he's going to ask you on the test. Now, because we don't have enough votes to move on, I will solve another example of exact equations. Let's say we have example 3. Where the problem is written as x dy over dx equals 2x e to the x minus y plus 6x squared So this is the problem. And the question is this equation exact? If yes, solve it. Now, first thing that you see here is that this equation is not written in the form m dx plus n dy equal to 0. So first thing first, you need to make sure you have m dx plus n dy equals 0. How do you do that? This dx is sent to the right. It becomes a coefficient of the thing. And then x dy is also sent there. So we are going to have 2x e to the x minus y plus 6x squared dx minus x dy equals 0. So first thing in this problem, we switch like this, and this is what we get. Wow. I think I have all my students in, but I see somebody is trying to get into the class. Do I have 24 students? I have only 23.
Nah, I emailed you. I have a class on campus, so I'm trying to switch to my phone.
Okay. It's now I see when you're talking that a name shows next to it. All right. Thank you. I remember that. All right. So we do this. And after doing this, we identify now our m and n. So m is what we have in front of dx, and n is everything including the sign that is in front of dy. Now we check that it is exact. dm over dy, what's the derivative of m with respect to y? Can you tell me?
Is it just -1?
-1, perfect. And then derivative of n with respect to x?
-1.
-1. And now you can see that these two things are equal. So the equation is exact, right? So we do have an exact equation in this case. Now, how do we solve it? Now I'm going on this example to do it the other way around, the way I was asked earlier. What would happen if we start that way? And why do I do that this way in this problem? Because I see here x e to the x and all those things, integrating them by parts. I don't want to do that. I want to do that integration by parts. So I go do this one because it's easy for me. So I start by that. F of xy equals integral of n dy. But of course, let me follow exactly the steps that I gave you earlier. I'm already skipping steps, right? Because whenever I'm happy, I start skipping steps. So we said derivative of f with respect to x is m. This is the first step. 2x e to the x minus y plus 6x squared. Derivative of f with respect to y is n. In this case, it's minus x. That's our first step, not to forget. Now, in our second step, that's where we do the integration that I was talking about. And here, because this function is a lot simpler than that one, I'm going to integrate this one. And because derivative is with respect to y, I'm going to integrate with respect to y to get f. So f of xy is integral of n dy, which is integral of negative x dy. And you tell me, what's the integral of negative x dy?
Negative xy plus h of x.
Good. Negative xy plus h of x in this case, because we took the integral with respect to y. So h is h of x. All right. Now the next step says, and we said if you do this, switch everything around. So now we are going to take the derivative of this with respect to x. So derivative of f with respect to x is, and this here is minus y plus h prime of x. And then in step 4, we are going to set this thing equal to m, the other way around. So negative y plus h prime of x equals m, and that is 2x e to the x minus y plus 6x squared. That's what it is. And then step 5 said solve for h prime. So h prime of x equals, you take this thing to the other side. So you get 2x e to the x minus y plus 6x squared minus y, that's plus y. And you can see that y's cancel. So that is 2x e to the x plus 6x squared. In the other way, I said x will disappear. And in this method, y will disappear. So you got h prime of x equals 2x e to the x plus 6x squared. So y disappeared, everything is just x now. And then the next step is integrate. So you integrate, you find h of x equals integral of h prime of x dx equals integral of 2x e to the x plus 6x squared dx. So that's h of x. And we need to integrate this. We can do this by parts, or we can just write down the answer if we know it. Right? In this case, this is x minus 1 times e to the x. When you integrate by parts, this gives you this. And this integral gives you 2x cubed. And we don't care about plus c because we know that it's coming next in the other step. And then you bring h of x, you bring h of x into the formula of f, which is right here in this problem. So you got f of xy or negative xy plus 2x minus 1 e to the x plus 2x cubed. And then step 8 says set this thing equal to c. So that is fxy equals c, which is same as negative xy plus 2 times x minus 1 e to the x plus 2x cubed equals c. That's it. Problem solved. End. And if you want to show me that you're smarter, you can also solve for y. In this case, it's possible, but it's not necessary. All right? So you get 2 times x minus 1 e to the x plus 2x cubed minus c over x. Again, I say it's not necessary to do that. You can just stop right there. And I encourage to stop right there. That's it. Any questions about this? If you guys have no questions, I've perfectly timed it. It's time over. And we'll meet next week. questions?